A group of researchers have recently announced that they have discovered a lake on Mars, and they are able to make this discovery by using an advanced radar technique that is able to peer through the Martian surface. So how does this experiment work? Could more of these lakes exist throughout the planet? What does NASA think about the data? And could life live in this underground oasis? Let's talk about that. If you're interested in learning a brief overview of this discovery, check out this video. But let's begin by talking about the mission itself. The European Space Agency's Mars Express orbiter entered orbit around Mars in December 25th of 2003. On board the spacecraft was an experiment called MARSIS, which, knowing anything that goes to space, of course, is an acronym. Now, MARSIS is made up of two 20-meter long radar booms and one 7-meter long radar boom, and it's capable of performing something called ground-penetrating radar. Now, in order to understand how exactly this technique works, we have to be able to look at what's happening both at the spacecraft end and at the Mars end. So let's start out by looking at what's going on at the spacecraft. So in order to get the precision or resolution that they want out of the experiment, the spacecraft has to be within 800 kilometers of the surface of Mars. And this might sound like a pretty large distance, however the Mars Express orbiter is actually only in that region for around 23 minutes, meaning it only has 23 minutes to perform the experiment during every one of its orbits. Now, as the spacecraft goes throughout its orbit or flies over the surface, it sends radio waves at frequencies of around 1 to 5.5 megahertz at 130 pulses per second. Or in other words, it shoots 130 signals down to Mars. So let's follow those signals and see what actually happens on the surface. So as the signals travel throughout the Martian atmosphere, a small percentage of them are reflected by the gas in the atmosphere. However, when the transition from gas to solid happens, a higher percentage is reflected back into space and then go back to the spacecraft. However, not all of them. Some of them make their way through the surface and are reflected by different transitions, whether it be from one mineral to the next, rock to ice, or ice to liquid, in terms of ice to liquid water. And each one of these transitions reflects a different percentage or of a different amount of the signal that passes through. Therefore, bright spots or dim spots in what is received could then be seen to be different types of transitions from one rock or one object to another. So now that we've seen the reflections from different transitions within the soil, let's go back to the spacecraft and see what it's able to do. So the first signals it's going to pick up are the ones from the surface, and it actually is able to use its 7-meter boom to see what those values are and then to get rid of them for the rest of the data, because we're not trying to understand what's on the surface, but rather what's underneath, hence the name ground penetrating radar. Then a few moments later, the reflections from underneath the surface arrive. However, since these are much smaller and much dimmer than the surface samples, a special technique called synthetic aperture has to be used. So let's briefly describe that. To start, aperture is used to describe how much power or how many signals an antenna can take in, which is why you could see massive telescopes or massive radio antenna that are capable of picking up things much farther away than your typical car antenna would be able to. But synthetic aperture accounts for the fact that the antenna is actually moving. Since the spacecraft or the MARSIS experiment on the spacecraft is moving throughout its orbit, it experiences a slightly larger aperture, meaning that it can pick up radio waves that are occurring both at its previous location and at its current location, representing a slightly larger aperture size. So this effect actually allows us to pick up a few more signals than we typically would be able to with a smaller aperture or a fixed aperture. So using this technique, the radar booms are capable of picking up the signals that are coming back from underneath the surface. And that's how the experiment works. Now, this process of ground penetrating radar is commonly used here on Earth. In archaeology, it's used to see if there are certain regions underneath the ground that could possibly show interest in finding a new archaeological site. For military uses, they use it to see if there are new tunnels or new ways that they can try and get into a certain location. And for a more recent use, they've been trying to figure out a civil engineering technique where they can see where people are capable of parking their cars. That's because here on Earth, they're able to get accuracy or precision down to the 10 centimeter range. But that's mainly because these spacecraft are at lower altitudes, or they're using aircraft to be able to do the same thing. Meaning that overall, if you're closer to the surface, you can achieve a higher precision or a higher resolution. But let's go back to Mars. Up until 2002, the research team was running into quite a few problems with the experiment. It was able to pick up data, however, not at the resolution they want. And this is because once the experiment received the signals, it actually processed them on the spot and then sent the fully processed data back to Earth. However, they sent a software update to the spacecraft. Yes, spacecraft do receive software updates. And in this, it said, all we want you to do is collect all the data you possibly can during each one of your orbits, and then send all of that data back. And this happened to be much slower just because of how much communication had to go back and forth between the spacecraft and Earth. However, in the long run, it greatly improved the resolution of the images, which was led to the discovery that it was just recently made. Now this is what the image would look like after the data is processed, and in fact this is what the European Space Agency released when the announcement was made that they found a lake on Mars. So let's take a look thinking about how the experiment actually works. Near the top there is a horizontal line that is fairly bright. This is representing the surface of Mars. As I mentioned, a high percentage of the signals are reflected right away, which is why we see this bright signal right here. Then once we go underneath there, we see strange shapes, weird lines, probably representing a transition from sediment to ice or different minerals one to the next. And then as we continue down a little bit further, we see another bright spot. This is where scientists theorize that this is the transition from ice to liquid water. Now this image represents only one of 29 that were used to determine that this could possibly be a lake on Mars. And they scanned the same 200 by 200 kilometer area and found that this region is approximately where they expect it to be, where the darker blue triangle is. And if you look at this picture a little bit more, you can see how there's strange lines making this shape. It's not a perfect triangle or rectangle, but rather almost like a bunch of streaks. And this is because this is every single one of the spacecraft's flyover. As it flies over this region, it looks directly down and sends these signals. That's why we don't see it as a perfect shape, but rather a lot of streaks or almost paint marks making up what appears to be where the lake would be. So this ends up being 3 years worth of data for the Mars Express mission, or for the MARSIS experiment. So could more of these lakes exist underneath the surface? The answer is probably, however we might not be able to know for a long time. And this is because the Mars Express mission is 15 years old and the end of lifetime for the mission is thought to be 2020, so just 2 years from now. And since it took 3 years to just collect this data, it's thought that it might not have enough time to find another lake. Unless they have a few years of data that they haven't analyzed yet, I doubt that they'll be able to make another discovery like this. But what about NASA? NASA sent a radar experiment on their Mars Reconnaissance Orbiter that actually had a much higher resolution than MARSIS. However, it isn't able to penetrate into the ground nearly as far as MARSIS. It can only go a few hundred meters rather than MARSIS that can go a few kilometers. And so it is thought that since the Mars Reconnaissance Orbiter hasn't discovered any of these lakes, that it's probably not looking deep enough, meaning it might not ever be able to find a lake of its own. Now that doesn't mean that they're not making progress. NASA recently launched the InSight mission, which is aiming to understand if Mars's inner core is actually radiating heat. And if it is, this could show that more of these lakes will probably exist and that it's actually warmer underneath the surface. Now what has NASA said or done in response to this discovery? Well, the chief scientist at NASA said, "The bright spot seen in the MARSIS data is an unusual feature and extremely intriguing. It definitely warrants further study, and additional lines of evidence should be pursued to test the interpretation." Now, other scientists at NASA agree with the current understanding that it could be liquid water. However, more ideas should be approached. And like any good scientist, they are up for investigation to see whether or not this is liquid water. So I expect in maybe the next few months to up to a year, we see more studies coming out with the same data to see whether or not this is actually liquid water, either proving that it's correct or arguing that it might actually be something else. But for this situation, let's say 100% there is a lake. Could life be in that lake? Well, first of all, on the surface of Mars, or at least in the region that the lake was found, the average temperature is around -65 degrees Celsius, which is far below the freezing point for water. So we first have to understand why it's not freezing. And this is mainly in two parts. As I mentioned before, the InSight mission is trying to understand if the inner core is radiating heat. And if it is, that means it could be warmer, meaning it's actually warmer underneath the surface. But it probably won't bring it up -65 to 0 degrees. It probably would only bring it up a little bit. Therefore, it's also thought that there are salts inside of the water, making it salt water. However, it's perchlorate. And if you remember from previous episodes, we've talked about perchlorate a lot because it's harmful to organisms, both plants and animals. However, there is an exception to this rule. Remember this guy? This is Archaeoglobus fulgitus, and we discussed it when we talked about creating oxygen on Mars for a future colony or mission to the Red Planet. Now, Archaeoglobus fulgitus is actually capable of turning perchlorate into safer chlorine and oxygen atoms or different molecules of their form. And this is important because they could actually live in this saltwater environment. However, there is a major issue. They can only live here on Earth in 80 to 90 degrees Celsius range, incredibly hot temperatures, which it probably isn't in this underground lake. Therefore, it probably doesn't exist there. So the answer to if life could possibly exist in this lake is we really have no idea. There are so many questions in terms of the stability of the water itself, how it's even staying in its liquid form, that how could we even guess if life could be there? It would be a complete shot in the dark. However, with further investigations and further studies, we might better understand why it's liquid, and that could help us lead to more predictions on if life could be there. So what do you think? Do you think life could possibly exist in this lake? Or rather, do you think there are more of these lakes throughout the entire planet of Mars? Let me know in the comments below. I'd love to hear your opinion. But thank you for watching, and I hope to see you in the next one.